back with 3 more examples. You can see we have a radical, we have an e, and we have a natural log of x. So take a look at this number 4 here. The integral from 0 to 4 of 3x times the square root of 25 minus x squared dx. I want you to go ahead and pause and see if you can set up that u substitution. Okay, so hopefully you paused and you have this u substitution set up. U is equal to 25 minus x squared. Du is negative 2x dx. So I don't need the negative 2 because I have a 3x here. So I'm going to divide that negative 2 out, get negative 1/2 du equals x dx. When x equals 0, u is equal to 25, 25 minus 0 squared. When x equals 4, u is equal to 9, 25 minus 16, which is 9. So that gives me, oops, don't want to give too many answers away here. That gives me the integral from 25 to 9. There's my 3. That x has been absorbed in the du, u to the 1/2, and then my x dx is negative 1/2 du. So I'm going to pull the 3 and the negative 1/2 out, and I'm going to switch the limits. So 3 times negative 1/2 is negative 3/2, and when I switch the limits, it's going to change the sign, and I get positive 3/2. Integral from 9 to 25 of u to the 1/2. Now all I have to do is integrate u to the 1/2, which would be 3/2 times u to the 3/2 over 3/2 from 9 to 25. Now you know me, I don't like number lasagna, so I'm going to multiply by the reciprocal. 3/2 times 2/3 u to the 3/2, and these guys conveniently cancel out. So I'm left with just u to the 3/2 from 9 to 25. Now I stopped here because I know that there's going to be some people who need a review here. I'm putting 25 in there. 25 to the 3/2 minus 9 to the 3/2. Lucky for you, on a free response, you can stop here. But if for some reason you need to use this answer in something further, you're going to need to know what this means. And remember, the bottom number is the root. The top number is the power. So the square root of 25 cubed. The square root of 9 cubed. So the square root of 25 is 5. 5 cubed. The square root of 9 is 3. 3 cubed. 125 minus 27 is 98. Okay? Next problem. Integral from 0 to 1 of e to the 2x minus 1 dx. I'm going to let you pause the video, and in a few seconds, the answer will appear. Okay, here's the first part of the setup. U is equal to 2x minus 1. Du is equal to 2 dx. I don't need that 2, so I divide it out. 1/2 du equals dx. When x equals 0, u is equal to negative 1. 2 times 0 minus 1. When x equals 1, u is equal to positive 1. So instead of going from 0 to 1, I'm going to go from negative 1 to 1. And it looks like this. All right? Integral from negative 1 to 1, e to the u. The dx gets replaced with 1/2 du. I pull that 1/2 out. I have 1/2 integral negative 1 to 1, e to the u du. That looks suspiciously like a 4. This is a u, not a 4. And what is the antiderivative of e to the u? E's are awesome. They are their own derivatives. Now there's a whole lot of stuff here, so let's go this way. So the antiderivative of e to the u is e to the u. So I get 1/2 e to the u from negative 1 to positive 1. I plug 1 in, so there's my 1/2. E to the first minus e to the negative 1. And then you're done there on a free response question. But again, your professors next year in college will want you to probably be able to get to some sort of an answer. And since you're not allowed to use a calculator, I'm just going to drop this e to the bottom. So I get 1/2 e to the first, which is just e, minus 1 over e. You could distribute the 2, which gives you e over 2 minus 1 over 2e. And then you can find a common denominator, which would be 2e. So you'd get e squared minus 1 over 2e. So if we were taking a regular AP exam, you could see an answer on a multiple choice written that way. You could see it that way. You could see it that way. And you could see it that way. Any one of those four would be fair game on a multiple choice. But on a free response, stop as soon as you get to this point. Okay? All right, last problem. We're integrating from e to e squared of the natural log of x over x dx. You might want to split this up so that it is natural log of x times 1 over x dx. That might help you out a little bit. I want you to pause the video and take this one for a spin around the block. See if you can do it. Okay, so hopefully you paused the video and you watched, or you tried it, and now you're back to watch to see if you did it right. I let u equal the natural log of x because I know the derivative of natural log of x is 1 over x. So that's the key to u substitution, is being able to let u equal something whose derivative is hidden in the rest of the problem. So du is 1 over x dx. When x equals e, if I plug e in there, the natural log of e is just 1, something you should remember from pre-calculus. And if I plug e squared in there, the natural log of e squared is 2. And if you don't really remember why that is, remember that a natural log is automatically base e. So you're asking yourself, what can I raise e to get e squared? And the answer is 2. So that's why this is equal to 2. All right, so I'm going to rewrite this thing. This was nice and convenient. E to e squared becomes 1 to 2. This was our u. This whole thing got absorbed by the, oh, this is supposed to be a du. And we can just integrate u. 1/2 u squared. Some of you may want to write it u squared over 2. Doesn't matter to me. From 1 to 2. Why is that 2 all the way over there? Boop, right there. And then we plug in our 2. 2 squared minus 1 squared. 2 squared minus 1 squared is 3. So 1/2 times 3 is 3/2. On this year's AP exam, stop here. No need to go any further. Right? If this was multiple choice, they'd probably have this as an answer, but there's no multiple choice on this year's exam. Okay? All right, I'm going to give you guys some practice problems to do. I hope this has made some sense to you. If not, send me an email.